One of the benefits of using celastic moldable optical silicones is the ability to reproduce fine detail from the molds. There are many reasons for adding texture to a component, and there's a wide variety of surface finishes or textures available from different companies that can be incorporated in a part. Texture is often used simply to improve the tactile feel of a part, or to increase moldability, like having the part remain selectively on one side of the mold. But for our discussion, we're more concerned with how the surface finish can affect light transmission through the piece. One end cap included in this kit is highly polished. Any light transmission losses through this cover cap would be mainly due to surface reflections on each side of the cap. The mold for the next cap has been surface blasted with 3 mil glass beads. This process produces a matte surface that provides diffusion of the light with only a small amount of transmission loss. The next end cap reproduces a chemically etched square grid diffusion type structures. This chemical etching process produces a surface with a diffusion of light similar to the bead blasted surface. The surface structures are about 75 microns deep. Note that this type of structure, and a myriad of others, could also be created using a laser engraving process on the mold tool. The last cap features a more intricate surface. The molded pattern is a set of flakes or chips that have grooves across them. These grooves are just 0.5 to 0.8 microns deep and are 2 to 4 microns apart. At a 2 micron spacing, that would be approximately 500 grooves per millimeter. This fine pattern acts as a diffraction grating. It diffracts or splits the light into a series of rainbow spikes around the center beam when placed over the collimator lens on the flashlight. The splitting effect can also be seen by shining a laser pointer through the cap. A circle of smaller dots will appear around the central main beam. Care should be taken to keep the inside pattern surface of this cover clean. Oil from fingerprints can fill in the fine grooves and negate the diffraction effect, but the part can be cleaned easily with soap and water or eyeglass cleaner. Once it's dry, the diffraction effect will return. Another benefit demonstrated with these silicone flashlight end caps is the design flexibility. The part snaps over the end of the flashlight's hood because of a bead that's molded on the inside of the cap. This provides tension, allowing a part to snap fit onto the hood. It also provides sealing benefits to keep dirt, abrasions, and the elements away from the flashlight lens.